Imagine a world where damaged organs can be replaced on demand. Where the wait list for a life-saving transplant is a thing of the past. It sounds like science fiction, right? But what if I told you that science fiction is rapidly becoming reality? We're diving deep into the revolutionary field of bioprinting. Forget printing on paper. We're talking about printing living tissues and potentially entire organs. In this video, we'll explore the fascinating science behind this cutting-edge technology. We'll uncover how bioprinters work, the incredible progress that's already been made, and the ethical considerations surrounding this game-changing innovation. Get ready to witness the dawn of a new era in medicine, where the future of organ replacement is printed. So, how did we even get to the point of printing organs? It's not like this sprang up overnight. The history of bioprinting is a fascinating journey of incremental discoveries and leaps of imagination. Let's rewind to the early 2000s. The seeds were really sown by researchers like Thomas Boland at Clemson University. He's often credited with adapting inkjet printing technology, yes, the same tech in your desktop printer, to deposit cells instead of ink. This was a huge turning point, showing that precise cell placement was actually achievable. Around the same time, other pioneers like Vladimir Mironov were exploring different approaches. Mironov championed the idea of tissue spheroids, essentially self-assembling clusters of cells, as building blocks for larger structures. He really pushed the idea that we could recreate functional tissues using these mini organs. Then, in 2003, we saw the formation of Organovo, one of the first companies dedicated to commercializing bioprinting. This marked a shift from purely academic research to a more industry-focused endeavor, driving the technology forward with new resources and ambition. These early years were crucial. They established the foundational principles of cell deposition, bioink development, and tissue engineering strategies that we still rely on today. It was a collaborative effort, a global conversation between scientists and engineers, each building upon the work of the other. So, where are we right now with bioprinting? It's not quite ready to churn out replacement hearts on demand, but it's already making a real impact in several key areas. One of the biggest is drug discovery and testing. Imagine being able to test new medications on a 3D printed model of a human liver, complete with functioning cells and blood vessels, instead of relying solely on animal models or simple cell cultures. This offers a more accurate and ethical way to predict how a drug will behave in the human body, speeding up the development process and potentially reducing harmful side effects. Several pharmaceutical companies are already using bioprinted tissues for this very purpose. Another significant application is in creating personalized implants and surgical guides. For example, if a patient needs a bone graft, bioprinting can be used to create a scaffold, a kind of framework, perfectly matched to their specific anatomy. This scaffold then encourages the patient's own cells to grow and regenerate, leading to better outcomes and less chance of rejection. We're also seeing bioprinted surgical guides that help surgeons perform complex procedures with greater precision, minimizing damage to surrounding tissues. And finally, let's not forget the potential for advancements in regenerative medicine. While we're not quite there yet, researchers are using bioprinting to create skin grafts for burn victims, cartilage replacements for damaged joints, and even small-scale models of organs to study disease. These advancements offer hope for treating conditions that were previously considered untreatable, and improving the quality of life for countless individuals. The impact on society is potentially enormous, offering everything from more effective drug development to personalized medicine and, ultimately, a longer, healthier lifespan for all. So, to recap, we've seen how bioprinting is revolutionizing medicine by using bioinks made from living cells to create functional tissues and potentially entire organs. We've explored the different bioprinting techniques, from extrusion to inkjet, and seen their potential applications in drug testing, regenerative medicine, and even personalized implants. While still in its early stages, bioprinting holds incredible promise for the future. Imagine a world where organ transplant waiting lists are a thing of the past, where damaged tissues can be perfectly repaired, and where new drugs are tested on human tissues grown in a lab. It's a bold vision, but one that bioprinting is steadily bringing closer to reality. The next decade will likely see significant advancements in bioink materials, printing resolution, and the complexity of printed tissues. We might even see the first bioprinted organs successfully implanted in humans, marking a pivotal moment in medical history. If you found this video informative, make sure to hit that like button. And to stay up to date with the latest breakthroughs in bioprinting and other cutting-edge technologies, subscribe to our channel. We've got plenty more exciting content coming your way.
I got broads in Atlanta, just took the lean in the family, credit cards and the scammers, hitting the licks in the band, legacies.